Hi all. Today our topic is sound. So I am going to take only introduction to sound. So what do you mean by sound? We have seen heat. We know about light. Heat, light, they are all forms of energies. They travel in the form of light is also travel in the form of waves. Sound also travel in the form of waves. Sound is a form of energy. It makes sensation of hearing. So the sound energy travel in the form of waves which bombards the eardrum. So we are sensing the sound. So sound, what is the audibility of sound or audible limit of the sound? How much frequency of sound human ear can hear? Frequency 20 Hz to 20,000 Hz, between 20 Hz to 20,000 Hz of frequency of sound human ear can hear. Below 20 Hz, the frequency of sound is below 20 Hz. It is called infrasonics. The study of frequency of sound below 20 Hz is called infrasonics. The study of frequency of sound above 20,000 Hz is called ultrasonics. But a human ear have no potential to hear below 20 Hz or above 20,000 Hz. So only audible limit is 20 to 20,000 Hz. Sound travel in the form of waves. It will travel in the form of longitudinal wave. There are two types of wave motion: longitudinal waves, transverse waves. Sound travel in the form of longitudinal wave, whereas light waves travel in the form of transverse waves. Light waves as like water waves, surface water waves. Suppose you are going to a well, it is very silent, you are dropping a stone in the center of the well, so the waves goes like this. So it reaches the ends and vanishes. So the particles of the medium vibrate perpendicular to the propagation of the wave. The particles of the medium vibrates perpendicular to the direction of the propagation of the wave. It is called transverse wave. So the light waves are transverse wave. If the particles of the medium vibrate parallel to the direction of the propagation of the wave, it is called a longitudinal wave. From tuning fork, with the help of rubber hammer, we are vibrating it. So the waves coming from tuning fork is example for longitudinal wave. So the particles of the medium where it is very dense, that is called compression. Where it is very less dense, it is called rarefactions. So alternate compressions and rarefactions form the longitudinal wave. Here alternate crest and trough form the transverse wave. So the maximum upward displacement is called crest, maximum downward displacement is called trough. So one crest, one trough, they form a wave. The length of the wave is called wavelength. So these are all the preliminary things about the wave nature. So it travel in the form of longitudinal wave. Sound travel in the form of longitudinal wave. So musical sound is also a sound. Noise is also a sound. Whereas there are some differences between musical sound and noise. Musical sound is pleasant to hear, but noise is unpleasant to hear. Music heals our mind. Noise, it ills our mind. Wave nature is regular in musical sound. Wave nature is irregular, whereas in the noise, there will be sudden change in amplitude in the noise, but there is no sudden change in amplitude in the musical sound. Suppose if you take pitch, intensity, quality, they are all main factors. They affect the quality of sound. Pitch, intensity, quality. They are all in the specified limits in the case of musical sound. There is no specified limits. There is no uniformity in the noise. And one more thing, we can create the musical sound with regular vibration or with the help of musical instruments, veena, guitar, harmonium, tabla, so on. But noise, we cannot give, these are all only examples, we cannot say. We can see any example. Thunder sound, barking of the dogs. In public places, we are getting noise. In theatres, we are getting noise. So we can give more examples to the noise. Nearby stone crushers, they are blasting the stones. So you are getting the sound. It is also called noise. So there are so many examples for noise. So regarding noise pollution, we will see in the next video lecture. So just I have given the introduction to sound. Thank you very much.